have to do with isotopes. On the screen now, you can see the annotation or the notation that we'll be using to talk about isotopes. You can tell that the mass number here is listed at the top and the atomic number is listed at the bottom. Now, some of my students have been frustrated because this is generally reversed when it is listed on the periodic table. You can determine which one's the mass and which one's the atomic number by noticing which number is larger. Remember that the mass number always has to be larger than the atomic number. That's one way to keep it straight. But again, you can notice that when we have an isotope, the symbol will be given to you here, the mass number will be given to you here, and the atomic number will be given to you here. Here you can see this annotation in action. You can see that we're looking at two isotopes of neon. We have neon 20 and we have neon 22. Take a minute to think about what that 20 and what that 22 actually stand for. You can notice here that the 20 that comes after our first neon stands for the mass number. One reason that we can tell that this is the mass number is because we have a mass number here of 20 and the atomic number of 10 on the bottom. Notice between our two isotopes that the 10 on the bottom stays the same. Remember that that's because the atomic number of isotopes is the same. The thing that's changing is our neutrons, which means that we have a changing mass number. You can see that illustrated here by the neon, which has a mass number of 22, versus our first neon with a mass number of 20. Sometimes when you're given isotopes, you aren't going to be given out this full annotation with the mass number and the atomic number. Sometimes you're just going to have the name written with a number following. One thing to keep in mind is that that following number is always going to be your mass number. Think about where you could find the atomic number of an element. Since in this case, the atomic number is not given to you, just the mass number. Our atomic number could be found on the periodic table. Now, oftentimes when you're given isotope questions, they're going to ask you to figure out the number of neutrons in this particular isotope. Now, there's two steps that you'll have to follow to figure out the number of neutrons. The first step is that you're going to have to figure out this set of information. Figure out the mass number, the atomic number, and the number of protons. Now, all of this information is actually given to you in this annotation form right here. You can see that the mass number is going to come from the top number, 13. The atomic number is listed on the bottom, number 6. And the number of protons is also listed because it's the same as the atomic number. Now, with this information, to figure out the number of neutrons, all you have to do is subtract the bottom number, the number of protons, from the top number, the mass number. You can see here that we do 13 minus 6, and that gives you the number of neutrons, which is 7. This is very similar to the work that we were doing in class on Tuesday when we were figuring out the number of neutrons in an atom. Now that you've completed this, you're going to practice this skill using the worksheet in your interactive notebook on page 31. Here, you can practice finding the mass number, number of protons, neutrons, and electrons for 3 different types of potassium isotopes. One piece of information that you're going to need to know is the atomic number for potassium. We could find this information on the periodic table, or you could look up the atomic number for potassium with using Google. Please practice this skill by filling in that chart on page 31. Let Miss Mack or Miss Hartzell know if you have any questions. Good luck!